Hey everyone, good morning. What did we do in the last class? We discussed about the artificial neural network, right? So today we'll do the implementation. Let me upload new dataset into your drive. So please download and upload into a Google Colab. Yeah. Please download data and upload. And we'll do the implementation. Then uploading. So if you look into your dataset, it's a loan approval dataset. So we have to build artificial neural network in order to predict whether customer will get a loan or not. There are certain factors like loan ID, gender, marriage or not, dependence, education,
Dito
self-employed,
nagpasa sa labas,
applicant,
merit. Gita,
applicant income.
Ay,
Loan
hinugaplan madam,
amount.
may kitu ko tagad.
Can you guys please mute? So these are the factors which plays a very important role in order to say whether a customer will get a loan approval or not. It's an interesting one wherein banks can implement this whenever the processing becomes like very high. Let's say, for example, coming to our urban cities and all, the amount of people who apply for loan will be high. Instead of employees analyzing everything, they can just use an ML model, something like this, which can basically help them in understanding who is applicable for a loan, who is not. So it saves time and the process will be like more effective. So that's how machine learning algorithms are going to work. So you can implement all the algorithms that I've taught so far extra. So since I want to show like how ANN works, so I'll be showing for just data. So if you want, you can implement all the algorithms that I've taught so far. Okay. I hope you are done with uploading data. If done, start importing libraries, load the data. We'll import NumPy as NP, import pandas as PD, and then import matplotlib, dot pyplot as PMD, and then import Seaborn as SNS. And then just load our data equals PD dot read underscore CSV. You can just mention loan approved dot CSV. So this is our data set that we have. So once this is done, start doing all the basic checks and explore your data. Doing basic checks. So data dot shape. So 614 rows and 13 columns we have. Data dot head. You could see there are certain missing values. And then data dot tail. And then info just to check the memory usage. Check data type of each column, data dot data each. And check whether data type is correct or wrong. Print all the columns, data dot columns. And all the numerical columns. Include equals object. And I have a categorical columns, data dot select underscore data each. Sorry. This is categorical columns. You can see the column which has the text kind of data, but if you look into our dependents, even though values are numbers, the data type showing like an object. You know why? Because of this 3 plus. Since 3 plus was taken as a string, so it is converted into a string format. Okay. And then for numerical column, you just include integer 64 and a float 64. See all the numerical columns. Then you could perform a statistical analysis later or describe. So clearly no standard deviation or zero, that means no constant columns. Find all unique values as well as find all value counts. Just check out all the unique values using a for loop. Use a for loop. Done. So for X and categorical columns, print data of X dot unique. If you want to see the column name as well, you can just customize like this. So actually loan ID is not required. You can just use data dot drop columns equals, you can just drop that loan ID. And rest all you can take it up. But yeah. If you want the value counts, take the same code. So it just tells you like how many values are there with respect to each. This is how you find unique values and a value count. Done. All right. The next important step is Handle missing values. Before you handle, first check are there missing values in our data. Just use data dot is not a dot sum. So there are missing values in our gender column, married column, self-employed, loan amount term, and also credit history. We'll just make a list of all the columns. So gender, married, we have dependents. Then you have self-employed. Then you have loan amount. Loan amount term and a credit history. So we need to replace all those columns, missing values with relevant values. So I'll start one by one. First one, gender column, its data type is obviously the object. Still, if you want, you can check. Since it's an object, I can directly go with a mode. Most frequently occurring values are male. And then I'll be replacing calling the column equals column dot fill NA, fill it with most frequently occurring value. Done. Done with a gender. Same way, do it with married. I married, self-employed. First, check the data type. It's an object. So find the most frequently occurring value. It says yes. Fill it with most frequently occurring value. That's it. Done with married. Same way do it for self-employed. Be smarter. No point in typing everything. Done. This is how you replace missing values in a categorical column, most frequently occurring. Try with dependents. Use mode only even for dependents. So clearly dependent data type is an object. Even though it has a number, but still it's a discrete. So you cannot go with mean or a median. Okay, so I'll be finding a mode. So most frequently occurring value is a mode. Done. Can you see? Gender, married, dependents, self-employed, everything got replaced. And let's take up credit history as well. Like, are you done till here or still doing?
Done, ma'am.
Okay.
Done, ma'am.
So what to do with our credit history? This is a credit history column. It's a numerical. Should I go with a mean, median, or a mode?
Mean or median, but we have to check for distribution.
Okay. Whenever it's a numerical, don't blindly go with a mean or a median. When data is continuous, go for checking distribution and then deciding mean or a median. So in this credit history, so you could see only two values. Whenever you feel like a column has a distinct values, okay, see here, it's just 1 0. So if I try to take mean and median, credit history should be either 0 or it should be 1. So if I try to find a mean for this, if I try to find a median for this, don't you think its meaning itself is going wrong? Yeah. When it's a discrete, don't go with mean or a median. Better go with a most frequently occurring value only. Okay, since it has a two values, you can just go with a mode. It gives you one, even median gives you one only, but still you can go with the most frequently occurring credit history and you can fill with that. Got it? Understood? Be careful. Not blindly applying a technology. You should understand and you have to implement it. So fill NA, fill it with most frequently occurring value in a credit history. Still, if you try to plot graph for it, it's just 0, 1. It just shows a discrete distribution. You don't understand much, right? Anyhow, again, it might show you a right tail, and if you go with a median, so you'll get a median 1 only. But still always remember, whenever it's a discrete, very few values you have, just go with the most frequently occurring value instead of going with a mean or a median. Always check the values. See, mean was giving a 0.8. So according to this data, 0.8 credit history is not acceptable. So we're not supposed to give that. Hope it's clear. This is all about handling missing values when it comes to a discrete and a categorical column. So we are left with two more columns. Hope you understood and hope it's done till here. So we'll go with loan amount now. Yeah, what to do, how to replace in loan amount. Same, check the data type. Probably it might be numerical. Check the distribution. Decide should we go with mean or a median. If graph is not clear, go with a skewness and then decide it and corresponding value and fill it. Come on, give it a try. Done? It's a float 64.
Online संगठन में उससे क्लियर दोस्त करते
So what kind of distribution is this? What kind of distribution? Even from graph, even from skewness, it clearly shows that it's a right skew. So just find a median. And just fill it with a median. That's it, done. This is related to loan amount. Same way, do it for, we have one more. So loan amount term. Finish this and do it for loan amount term. Done.
Yes, ma'am. 10, ma'am.
Data type is float, right? Okay. Even in this loan amount term, first you can check the unique values once. See it like 360, 120, 240, 180, 60, 300. So well, in this case, you need not go with the most frequently. You can try with mean or a median only. So just check. So PLT dot figure of fixed size equals. I come on to let me copy paste. So what kind of distribution is it? It's like negative skew because you have values more towards a negative side, right? Like lesser values are more. So again, you can just go with a median. And one more thing, like even if you find a mode, median mode might be the same when it's a skewed. Okay, when it's a skewed, usually median and mode will be the same, even though it's a discrete. Okay, so you can pick median as well instead of going with a mode. So it's a 360 dot Falani. Done. Hope it's clear. Any questions?
Understood, ma'am.
I'm not doing ADA. Anyhow, you know it. You do ADA. I'm not really wasting my time in doing ADA. Already understood. So we'll handle outliers and rest of the things. Okay, once we fill all the missing values, the next important step is like handling outliers. So what is the first step that we have to do? You can try finding outliers in these two columns. These are the two numerical columns. First, check are there any outliers? Then check the distribution. So I'll be just using a subplot. There should be one more column, I guess, like loan applicant income. Yeah, applicant, yes. Take one more. So there are outliers in all three. Let me check the distribution. If distribution is not giving a proper clarity, you can just go with the skewness. Okay, decide which kind of distribution and what should we use. What kind of distribution all three representing? It's a right skew. Right skew in the sense like which method we have to use in order to identify the outliers. Use an IQR. Try implementing IQR method for all this. And also take a break. People who don't want a break, please continue doing an IQR method and please finish it. People who want a break, please take a break. You people are back. So we'll start with co-applicant income and we'll try to implement an IQR method since all the distribution are right skew. So Q1 equals theta dot log of 1 of 0.25. Similarly, Q3 to 0.75. And then find an IQR using Q3 minus Q1. And then what next? You have to find a lower limit. So lower limit equals Q1 minus 1.5 times IQR. The limit is Q3 plus 1.5 times IQR. Have to filter data which is greater than upper limit, less than lower limit. I'll be using both the conditions together. First condition, if it is less than lower limit. Or second condition, if it's greater than upper limit. There are certain values. So I'll just find length of it. So it's 2.93%. So since less than 5%, you have to replace it with a median. I'll just use data.log. Data.log, this condition, you have to tell in which column you are doing changes. So it's a co-applicant income. So we'll be replacing with co-applicant income dot median. Hope it's clear. This is related to co-applicant. Similarly, you can try with the applicant income. So import only change the column name. Done. If done same we do it for applicant income. You have many values here, we will find a lens. Well, since percentage of outliers is more than 5%, I'm not touching them. Let it be as it is. Then I'm switching to loan amount. So it's 6% more than 5%. Again, we are not touching this. So this is how we handle the outliers. Just let me know once you are done. Is it done? If done, what should be the next process? We need to perform encoding. So tell me what type of encoding I have to apply for each column. So tell me for gender, like which encoding works. For married, which encoding works. For education, which encoding works. For self-employed, what works. And for property area, what works as well as for our loan status approach. So these are the columns which basically has a text kind of data which need to be converted into a number before we train a model. So gender has a values like male and a female. So which encoding technique we have to use here? So when I see gender, so you have male, female, equal importance should be given. So let's go with the one hot encoding. So coming to a married, it's like S no. Just go with the label encoding. When it comes to an education, you have a different levels. So just go with target encoder or a manual encoder based on a priority. Self-employed is also S or no. So just go with the label encoder. So property area. So again, loan approval depends on like whether you are in urban, rural. So even that matters, right? So just go with the target encoding even in this case. And then loan status approval, it's just like S no. You can just use the label encoder. And one more, you have a dependence as well. Independence, since we have the 3 plus, replace 3 plus with just a 3. Okay, so let's pass it as a number. And with 3, anyhow, 3 plus in the sense 3 plus or 3, one and the same represents. So you can just replace with a 3. So first try performing label encoder for all the columns that have listed. Understood, this is how you have to make a decision and you have to perform, not blindly implementing what you know. Think, understand, justify what you are doing. So that makes you a data scientist, not just implementing. Come on, do it. Is it done? First step, we'll go with the label encoder from sklearn.preprocessing. Import label encoder. So since for label encoder, you have to change a column name, I'm just changing the column names. So create a new column. So we need to drop the old columns now. Dropping permanently. Done. This is related to label encoder. Now we'll just go with the gender and just perform a one hot encoder. You can see. So only left with property area and education as well as a dependent. First go with an education. So it has a graduate, not a graduate, and something else. Let's see what are the unique values available in this. Okay, we have two things, graduate and not a graduate. Should we give equal importance to this? No, right. So graduate should be given a high importance. We'll just do a manual mapping. The dot map. Graduate will be given high importance. Not a graduate will be given less importance. Done. And then we have a property area. Just plot a graph for this. Tell me which should be given high importance. Just let me assign to a new variable education. So first importance, look into the orange bars, loan status. So semi-urban, let me give a use the same spelling. Let me give two. Next highest is urban. Drop the columns education as well as a can you see? Education. Education spelling might be wrong. That's the issue. Graduate and not graduate. Okay, again properly. Let me read on once. Yes. Can you see? Everything created. Only thing left out is you have to drop this loan ID, not important, and dependents should be changed. So we need to replace 3 plus what? 3. So I'll call data.log dependents dot replace 3 plus with a 3. Now let me check the data type once of dependents. It still shows an object. Let me assign it to a new variable D. Whenever you do replace or replace, you cannot set a data frame with multiple columns to single column dependents. Yeah. Still it shows an object. Only a number is getting changed anyways. String is always a dominant. Okay, no worries. We'll just do as type. So I'll just call data.log dependence dot as type. I'll just say integer 64. I'm replacing and I'm just doing typecasting. You can see new dependence column got created. If you want to see the data type, you can see it shows like an integer. So let me drop the old one. So done. So what is the next process? What next? What should be done? Clear? Understood. What next? Apply scaling. Can use standard scaler or min-max scaler you wish. Apply scaling on all these four columns. Don't apply apply on our credit history. It's already 0, 1. Apply on all these columns. So I'm going to implement a standard scaler. So from my scalar dot model underscore selection, just import. Standard scalar.
ಸುಮ್ಮನೆ ನಿಂತಿದ್ ನೋಡಿ ನೀನ್ ಅಲ್ಲಿ ಎದ್ದಿದ್ ತಗೊಂಡಾಗ
So in this case, the column should be passed as a 2-dimensional. Yeah, it's from a pre-processing, sorry. Same way do it for quartile income. I'm applying scaling for all the numerical columns. Done. All done. So just drop this loan ID. It's not really important. Rest all is good to go. Done. Now just split your data. Remaining splitting for training, testing, implementing model will do it in our next class. If you can try implementing MLP classifier. Okay. Done. Okay, thank you. We'll catch up tomorrow.